Good morning, or good afternoon, good evening. Don't know when you're watching this or listening to this. So, this is our first lecture on the immune system, where we're going to talk about immunity, the ability to resist disease, to resist pathogens, foreign things, whether it's bacteria, viruses, protista, worms, whatever you might have. And you have all these things. You encounter all these things all the time. But normally they don't knock you down because of your immune system, your amazing immune system. So we're going to divide the immune system up into a couple big groups. Two, in fact. There's innate immunity. This is the immune system you're born with. This is the one that responds immediately to a whole ton of stuff. It doesn't really care what the stuff is. It just cares that it's foreign and either tries to prevent it from getting in or just kills it, smacks it down. But again, not really caring who the invader, who the infectious agent is. Downside of this is if you don't care who it is, you don't get any better. You don't learn from your experiences. This is going to include barriers like skin, mucous membranes, as well as some non-specific internal defenses, including cells, some we met before like macrophages, chemicals like interferon, and also responses like inflammation and fever. So that's one of the things we're going to do first. We're also going to go over the adaptive immunity. This is a more delayed response, but it lets you respond particularly to specific antigens, specific foreign things. And this is where your T and B lymphocytes are going to work. And bear in mind, B lymphocytes turn to plasma cells, which make antibodies, and those are a crucial component of adaptive immunity. The word adaptive is really crucial here. The word adaptive implies, obviously, adaptation. And an adaptation, it has a positive connotation. It has the idea of getting better, of responding to something in a way that lets you perform at a higher level. And that's what you're going to do in this adaptive immunity. You're going to learn from the invaders and learn how to respond to them better next time. So this is a much more specific system because in order to improve, well, you got to be able to recognize things, and that requires specificity. All right, don't worry, we're going to break this stuff down in great detail. So overview, innate immunity recognizes and destroys foreign things like that weird looking parasitic worm right there, but the response doesn't require any specific recognition. And there's the downside of this, of course, is it's not going to result in any memory or in any adaptation, any improvement. And we're going to talk about both barriers as well as cells and chemicals. Again, active immunity recognizes and destroys foreign things. This is the province of our lymphocytes. There's a lymphocyte. Now, lymphocytes will specifically recognize things. They'll be able to distinguish between different varieties of bacteria, viruses, etc. And in doing so, in having this specificity, that creates memory. Memory allows for improvement, which is the whole point of your adaptive immune system. All right, so we're starting with innate stuff, barriers. You guys did the scan in ANP1. It's an awesome barrier. Its awesomeness is due to several reasons. Number one, it is stratified. Obviously, the epithelium here in the epidermis is stratified squamous epithelium. It is thick, hard for bacteria to dig their way through. And the cells on the top here are dead, filled with that protein keratin, which is tough and fibrous, hard to be degraded. And having dead skin cells at the top is good as well, because then you can permit, pathogen or just microbes in general to be there and not worry about it too much. And when you shed that dead skin, you can shed them away. Sweat, you're always sweating. You may not always realize it, but you're always sweating. You always have some insensible perspiration, and that is going to keep the pH of your skin slightly on the acidic side, which is bacteriostatic. It's going to help prevent the overgrowth of bacteria. So sweat gland, there's a cute little sweat gland right there. Always making sweat, keeping you slightly acidic. Meanwhile, sebaceous gland over here. Sebaceous gland is going to make that oily secretion sebum, which we know has moisturization purposes, but it's also bactericidal, so it kills bacteria. Now, another great thing about the skin is the normal residents, the normal flora, the bacteria that are there all the time. Remember, having normal good bacteria is going to allow them to compete for the resources that and then take them away from bad bacteria. All right, good stuff. More on barriers. Obviously, a lot of the barriers, not just the skin, but other barriers as well, including our tracts, our oral cavity, urinary pathway, our eyeball surfaces, are covered with body fluids. And one of the great things about body fluids is that they will physically wash pathogens away. Now, another great thing about body fluids is body fluids have a chemical in them called Lysozyme, which is an antibacterial enzyme, discovered by Mr. Fleming here, Professor Fleming. I told you the story about this in class, or I will tell you if you haven't heard it yet. So, body fluids contain lysozyme, an antibacterial enzyme. All right, moving right on. Now, the skin is a great barrier. It is not the only barrier. We also have our mucosae, or our mucous membranes. They're going to line all of our tracts: digestive, respiratory, urinary, and reproductive. All of these are potential entry points for pathogens. These are all the linings in these tracts are mucosae because they produce mucus. That mucus can be sticky and trap things, and that's especially the case in the respiratory system. That mucus can be acidic, which is especially the case in the adult stomach and adult vagina, and that acidity is going to be detrimental for bacterial growth. The secretions of the mucosae are going to include lysozyme. And also, we have the resident bacteria in all of these different tracts, and the resident bacteria are going to compete with the bad ones. Excellent. Let's highlight one specific, there we go, example, the respiratory mucosa. Respiratory mucosa is covered with a sticky mucus, which traps bacteria and other things. Pathogens, particles, and pollen are the three big P's that get trapped in respiratory mucus. Then, of course, we have the cilia, which are going to sweep this mucus up where you unconsciously swallow about a half liter of it every day. And that combination of mucus and cilia is known as the mucociliary escalator. Smoking, of course, destroys your mucociliary escalator, which will lead to bronchitis, in addition to emphysema and lung cancer eventually. So, other respiratory events. We have expulsive events in our respiratory tract. Sneezing, coughing, are other mechanisms that we're going to use to rid our tract of pathogens. All right, that's our example. Let's keep on going. Let's talk about some non-specific cells. Of course, we remember this polymorphonuclear leukocyte here. This is a neutrophil. Look at its awesomely multi-lobe nucleus. They're small, they're phagocytic, they are bacterial killers. Now, they don't care who the bacteria is. They just have a "you're foreign, I'm going to kill you" mentality. And they're the first to respond to sites of infection, sites of damage. All right, let's keep on going. Let's keep on going. And you can hear my daughter in the background right there. And now she's being quiet. So, eosinophils. More non-specific cellular defense. Eosinophils, of course, are great at killing parasitic worms. They try and kill parasitic worms. All right. More non-specific cellular defenses. And now she's hitting the door with a ruler. Great. More non-specific defenses. Macrophages. Macrophages are big. Of course, macro means big. Phages means they're going to do phagocytosis. They're going to engulf foreign things. We remember all of our macrophages are derived from monocytes. There are two big varieties. There's free and there's fixed. So macrophages in the lungs, which we have down here, these are known as dust cells. These are known as dust cells. And they're free macrophages. Free macrophages in that they've got to travel through the lungs to catch all the nasty stuff. Whereas the macrophages in our liver, these Kupffer cells, they are fixed. They allow the blood to come to them. All right, we're going to quit right there. Pick it up next time. See you later.